Welcome to the video lecture schedule of operations research. Today we will solve another problem by simplex method, that is by chance big M method. So here a maximization problem is given and two constraints are given. One is less equal to, another one is greater equal to. So the problem is max z equal to 3x1 plus 2x2 subject to the constraint 5x1 plus 3x2 less equal to 2, 3x1 plus 2x2 greater equal to 3 and x1 x2 greater equal to 0. So at first we will write the standard form of the given LPP. So what is the standard form? At first we have to add some variable in the first constant because it is less equal to, and we have to subtract some other variable from the second equation in the left hand side, then it will be equal to the right hand side. And since we are adding some variable in the first constraint, so that variable is slack variable, and we are subtracting some variable from the left hand side of the second constraint, that variable are surplus variable, and the coefficient of slack variable and surplus variable will be 0 in the objective function. So after adding the variable x3 in the first constant, we are getting 5x1 plus 3x2 plus x3 equal to 2, and we are subtracting the new variable x4 from the second constraint. We are getting 3x1 plus 2x2 minus x4 equal to 3. Now we have to find the variable whose coefficient forming the identity matrix in the constraint. So here what are the coefficient of x1 in the two constant? 5, 3. So it is not forming any column of the identity matrix because the identity matrix is 1, 0, 0, 1. Since two constraints are there, so the order of the identity matrix will be 2. Now the coefficient of x2 are 3, 2. It is also not forming. Coefficient of x3 are 1, 0. So it is forming one column. So x3 is one basic variable. Now coefficient of x4, that is 0, minus 1. So it is not forming because the another column of the identity matrix is 0, 1. But it is 0, minus 1. So that is why x4 is not the basic variable. So that is why we are adding another variable x5 in the second constraint to form the identity matrix. Now what are the coefficient of x5 in the two constraint? 0 and this is 1. So it is forming another column of the identity matrix. So x5 is the initial basic variable. So what are the initial basic variable? One is x3, another one is x5. Since we are adding x5 to form the identity matrix, that's why x5 is artificial variable, and the coefficient of the artificial variable will be minus capital M in the objective function, and the coefficient of slack variable x3 and surplus variable x4 will be 0 in the objective function. That's why the new objective function becomes max z equal to 3x1 plus 2x2, because initially it was 3x1 plus 2x2. So 3x1 plus 2x2 plus 0 into x3 plus 0 into x4 minus m into x5. So this is the standard form. Always we have to write the standard form at first. Since it is a maximization problem, so that's why there is no necessity to multiply it by minus 1, because if the objective function is a minimization problem, then only we will multiply it by minus 1. Now come to the table. Now we are forming the table. So again I am writing the standard form. So at first in this table we are putting the value of Cj. Already we know what is Cj. Cj is the coefficient of the variable in the objective function, j for objective. So what are the coefficient? 3, 2, 0, 0, minus m. 3 2 0 0 minus m. Now we will put the solution column, that is small b. So what is the solution of the first constant, that is 2, and what is the solution of the second constant, that is 3, 2 3. So here we are putting 2 3. Now xb, that is basic variable, initial basic variable. So who are the initial basic variable? x3 and x5. x3 present in the first constant and x5 present in the second constant, because they are coefficient forming the identity matrix 1 0, and this is 0 1. So x3 x5. Now here capital B, that means a3 a5, coefficient of x3 x5 in the general equation, and cb means coefficient of the basic variable in the objective function, that is 0 minus m. So x3 0 and x5 minus m, so 0 minus m. Now already we know we have to put the value of a1, a2, a3, a4 and a5 from the constant, that means the coefficient of the variable in the constant. So what are the coefficient of the variable in the first constant? 5 3 1 0 0. So here we are putting 5 3 1 0 0. Now coefficient of the variable in the second constant, 3 2 0 minus 1 0, 3 2 0 minus 1, and this is 1. It is not 0, it is 1, because x5, coefficient of x5 is 1. So 1. Now we will find zj minus cj. Already we know how to find zj, and cj is given at the top of the table. So what is zj? Summation of cv into ai. Already we have explained it previously. So cb column, element of cb column are 0, and this is minus m, because these are the variable of x3 and x5 in the objective function, x3 0 and x5 minus m. So 0 minus m. So 0 into ai, when I equal to 1, this is a1. 0 into 5 0, minus m into 3 minus 3m, minus 3j cj. What is cj? 3. So minus 3m minus 3. Similarly here 0 into 3 0, minus m into 2 minus 2m, minus 2m minus 2, minus 2m minus 2. 0 into 1 0, minus m into 0 0, 0 plus 0 0, 0 minus 0, that is 0. 0 into 0 0, minus m into minus 1, that is m, or m minus 0 m. So here it is m, and here 0 into 0 0, minus m into 1 minus m, and minus m minus cj. What is cj? Minus m. So minus m minus of minus m, that is plus m. So minus m plus m, that is 0. Now we have to find most negative zj minus cj. So here we are observing that minus 3m minus 3, minus 2m minus 2, these two values are negative. Now who is most negative? Minus 3m minus 3, because m is a very large number. So here we are giving a arrow mark. This arrow mark indicates this column. So this column is key column. Now we have to find the ratio, b column divided by key column. So 2 by 5, 2 by 5 and 3 by 3, that is 1. Now we have to find the minimum ratio. What is minimum ratio? 2 by 5. So give here arrow mark outward from the table. So this arrow mark indicates that the corresponding variable, that is x3, because here the variable is x3. So x3 will leave the table. In the next table x3 will not be present as a basic variable. And here this arrow mark indicates that the corresponding variable, this is coefficient is a1, that means corresponding variable is x1. So x1 will take place of x3. So x1 is the entering vector in the next table. So in place of x3 we will put x1, and x5 will be remains same. And similarly this one will be changed, a1 and a5 will be there, and here we will put a coefficient of x1 and x5 in the objective function. What is the coefficient of x1? That is 3. So 3 and minus m, this will be here. So come to the second table. Now here at first I am writing the previous table to understand it clearly. So x3 will leave the table, okay, and corresponding variable here x1 will enter into the table, and x5 will be as it is. So in place of x3 we are putting here x1, in place of x5 remains same. This is a1 a5, and coefficient of x1 is here. This is coefficient of x1 in the objective function, that is 3, and coefficient of x5, that is minus m. So here it is minus m. Now already we know what is the junction element of key row. This arrow mark indicates this row is the key row, and the junction element of key row and key column is 5. Mark it by box because it is a key element. Now we have to make this key element equal to 1. How we can make it 1? Divide this key row by key element, that is by 5. So we are getting here 2 by 5, 2 by 5, 5 by 5, that is 1, and this is 3 by 5, 3 by 5, this is 1 by 5, 1 by 5, 0 by 5, 0, and 0 by 5, 0. Now we have to make the other element of the key column equal to 0. That means what is the other element? 3. We have to make it 0 with the help of 1, which is occurring in place of key element. So how we can make 3 equal to 0 with the help of 1? If we multiply 1 by 3 and subtract it from here, we will get 0 here. So what should be the operation? The operation should be R2 minus 3 into R1. So what is the first element of R2? 3. Now what is the first element of R1? 2 by 5. So 3 minus 3 into 2 by 5. That means 3 minus 6 by 5. That is 3 into 5, 15 minus 6. That is 9 by 5. So we are getting 9 by 5. Here this is 5. So here this is 3. So 3 minus 3 into 1, 0. So in place of this is 0. Now this is 2. 2 minus 3 into 3 by 5. The 2 minus 3 into 3 by 5. That is 2 minus 9 by 5. 5 into 2, 10. 10 minus 9 by 5. That is 1 by 5. This is 0. 0 minus, and this is again minus. So minus of minus plus 3 into this 9. So here we are getting no. What is the second element? 0. 0 minus 3 into 0 minus 3 into 1 by 5. So we are getting 0 minus 3 into 1 by 5. So minus 3 by 5. Okay. This is minus 3 by 5. 0 minus 3 into 1 by 5. So this is minus 3 by 5. This element is minus 3 by 5. Okay. This element is minus 3 by 5. Okay. So again this is minus 1. Minus 1 minus 3 into 0. That is minus 1. So it is minus 1. And this is 1. 1 minus 3 into 0. That is 1. So 1. And this will be minus 3 by 5. Now again we are finding Zj minus Cj. So again we are finding Zj minus Cj. What is Zj minus Cj? 3 into 1, 3, minus m into 0, minus m. Sorry, minus m into 0, 0. 3 into 1, 3, 3 plus 0, 3, 3 minus 3, 0. Now 3 into 3 by 5, that is 9 by 5, minus m into 1 by 5, so minus m by 5. Tale, what is the value? Minus m by 5, and this is 9 by 5. 9 by 5 minus m by 5 minus 2. 9 by 5 minus 2. That means 9 minus 10 by 5. That is minus 1 by 5. Minus 1 by 5 minus m by 5. Similarly, we are calculating the other element. Here we are getting 3 into 1 by 5. That is 3 by 5. And this is minus m into minus 3 by 5. It will be minus 3 by 5. So this becomes 3m by 5. This will be 3m by 5. So it will not affect. So 3m by 5 plus 3 by 5 minus 0. So 3m by 5 plus 3 by 5. 3m plus 3 by 5. Okay. And this is 3 into 0, 0. Minus m into minus 1, m. M minus 0, m. And this is 3 into 0, 0. Minus m into 1, minus m. Minus m, minus of minus m. That is minus m plus m. That is 0. So 0. So here also we have to find the most negative. Here we are observing that only one element is negative. So here we are giving arrow mark upward direction. So this is a key row. So corresponding variable is A2 means x2. So x2 will enter into the table, and this is the key column. Okay, now we have to find the ratio. What are the ratio? 2 by 5 divided by 3 by 5. Okay, so ratio 2 by 5 divided by 3 by 5. So the element is 2 by 3, and this is 9 by 5 divided by 1 by 5, that is 9. So minimum ratio is 2 by 3 outward direction. So this is 2 by 3. Corresponding row is the key row, and the corresponding variable is x1. So x1 will leave the table. In place of x1 we will put x2. So in place of x1 we are putting x2, and this is x5 remains same, a2, a5. And what are the coefficient of x2 in the objective function? This is 2, because Cj, always Cj will be same. And what it is the coefficient of x5? That is minus m. Now come to the previous slide. So what is the key element? 3 by 5. We have to make it 1. That means multiply the key row by 5 by 3. So if we multiply it by 5 by 3, 5 cancel. So 2 by 3, 5 by 3, 1, 5 cancel, 1 by 3. Okay, so we are getting 2 by 3, 5 by 3, 1, 1 by 3, 0, 0. So 1 is occurring here. This is occurring in place of key element. Now we have to make the other element of the key column 0. So which one is the other element? Here the element is 1 by 5. We have to make it 0. How we can make it 0? With the help of 1 which is occurring in place of 3 by 5. That means we have to multiply R1 by 1 by 5 and subtract it from R2. So the operation should be R2 minus 1 by 5 into R1. So after doing this, we are getting the element 5 by 3 minus 1 by 3, 0, minus 46 by 15, minus 1, 1. We are getting this. Now again we are finding Zj minus Cj. That is 2 into 2 by 3, that is 4 by 3, minus m into 5 by 3. No, we are not calculating B column. 2 into 5 by 3, that is 10 by 3, minus m into minus 1 by 3, that is m by 3. So 5 plus 1 by 3. Okay, and minus 3. Okay, so after solving this, this is m into 1 m by 3, and this is 10 by 3. So 10 by 3 and minus 3. So 3 into 3, 9. 10 minus 9 by 3, that is 1 by 3. So 1 plus m by 3. 2 into 1, 2, minus m into 0, 0, 0 plus 2, 2, 2 minus 2, that is 0. 2 into 1 by 3, that is 2 by 3, minus m into minus 46 by 15, that is 46 m by 15. So if we add these two, this is 2 by 3 plus 46 m by 15. 2 by 3 plus 46 m by 15. 2 into 0, because Cj is 0. 2 into 0, 0, minus m into minus 1, m. So m plus 0, m minus 0, that is m. 2 into 0, 0, minus m into 1, minus m plus 0, minus m, minus m, minus of minus m, that is plus m. So minus m plus m, that is 0. So here we are observing that all Zj minus Cj get are equal to 0. So our optimal condition have reached. Now we have to find the solution from the basic variable and from the solution column. So who are the basic variable in the last table? x2 and x5. So what is the value of x2? x2 equal to 2 by 3. And what is the value of x5? x5 equal to 5 by 3. But x5 is artificial variable which is not present in the original problem. What is the objective function of the original problem? This is the objective function, max z equal to 3x1 plus 2x2. But there is no x5. Now what is the objective function of the standard form? This is the objective function of the standard form, 3x1 plus 2x2 plus 0 into x3 plus 0 into x4 plus minus m into x5. This is the objective function of the standard form. Now we have to put this value. If we put the value of x2 and x5, so x5 have some effect. because x5 is not 0 here. x5 is not 0 here, so x5 have some effect, so we are not getting the value of the original objective function. We are not getting the value of the original objective function. That's why this problem have no solution, because here we are not getting the value of the original objective function. So when the problem have no solution, if the artificial variable appears as a basic variable in the last table in non-zero level, what is the non-zero? 5/3, it is not 0, in non-zero level, then the problem have no solution. So this problem have no solution. So what we have learned? So in this chapter we have learned how to form the LPP at first, then we learned how to solve this LPP. There are several methods. One is graphical method, another one is simplex method. Already we know how to solve it by graphical method and how to solve it by simplex method. Now the question is, why we will solve it by simplex method? In the simplex method is a generalization method. In industry, the number of variable and number of constant will be more. If there exists only two variables, then only we can solve it by graphical method. Otherwise it is not possible. If the number of variable is more than 2, then we can solve it by simplex method. It is not possible to solve by graphical method. That's why we are using the simplex method. Now in the next class we will learn how to find the dual of a given LPP. LPP means of the given primal problem. The given LPP is called the primal problem. We have to find the dual of this primal problem. And in simplex method there are four methods are there. Not 4 methods. There are 4 type of solution are there. One is unique solution, another one is no solution, another one is infinite number of solution, and another one is unbounded solution. Unique solution means only one solution exists. Infinite number of solution when exists, when more than one solution exists, then the problem have infinite number of solution. And no solution, this type of problem have no solution. If artificial variable appears in the last table as a basic variable, then the problem have no solution. An unbounded solution, if Zj minus Cj, one of Zj minus Cj are negative, but we are not able to find the ratio, because in the key column if all the elements are negative, then it is not possible. We cannot divide the B column by 0 and negative element. So that means we cannot find the ratio. Already we have done this type of question also. So 4 type of solution are there, and already we have solved all the type of solution. Now thank you.